Good morning, my dear students. So, in this session, we are going to discuss Unit 9 Electrochemistry. The topics galvanic cell notation, EMF of a cell, and measurement of electrode potential. First, we will see galvanic cell. This diagram it denotes galvanic cell. It consists of two half cell. The left side it is anode compartment. Oxidation occurs. So oxidation half cell we can say a metallic zinc strip that dips into an aqueous solution of a zinc sulfate taken in a beaker. So likewise the right side another one beaker we have the right side reduction half cell. Here copper strip that dips into an aqueous solution of copper sulfate solution taken in a beaker. Now the oxidation half cell, when the zinc rod or zinc strip dipped in a aqueous solution of zinc sulfate, so oxidation occurs. Zinc turns to zinc 2 plus and 2 electron is released. So loss of electron, that's why we can say oxidation. Likewise reduction of cell, reduction takes place. Copper 2 plus accepted 2 electron and copper. It's a reduction. So both oxidation and reduction takes place. So we can say redox reaction in the Daniell cell. So overall reaction, how to write it? At the top we can see that zinc plus copper sulfate gives zinc sulfate and copper. Now here, so between the two half cell, salt bridge is connected. The salt bridge consists of potassium chloride or sodium sulfate. So now we have taken potassium chloride KCl, and the outer circuit from zinc rod to copper rod or strip is connected with a digital voltmeter. We can measure the volt, right? The diagram. Now the salt bridge, as I told you earlier, the salt bridge is to maintain the electrical neutrality in both the compartments, oxidation compartment, anode compartment, and reduction cathode compartment. The non-reactive anion Cl minus is from KCl taken the salt bridge, move from the salt bridge and enter into the anodic compartment. At the same time, some of the potassium positive ions move from salt bridge into the cathodic compartment. The completion of circuit. Electrons flow from the negatively charged zinc anode into the positively charged copper electrode through the external wire. At the same time, anions move towards anode and the cations are moved towards the cathode compartment. This completes the circuit. Now, galvanic cell notation. So how to explain the galvanic cell in the IUPAC convention? So here between zinc and zinc 2 plus one single vertical line is represented as. Likewise, copper 2 plus and copper, the same vertical line are given. So between the anodic and cathodic, double vertical line also is given. So what is the meaning? Single vertical line shows phase boundary. Phase boundary. Actually, the zinc rod dipped in zinc sulfate solution. It is a phase boundary. So right side also phase boundary is given. So copper dipped in copper sulfate solution. Double vertical line means salt bridge. Salt bridge between two half cell potassium chloride is the inverted U tube, it is taken. The salt bridge denoted as double vertical line. Now EMF of a cell. EMF of a cell. So we have learned that when two half cell of a Daniell cell are connected, a spontaneous redox reaction will take place which results in the flow of electron from the anode to cathode. The force that pushes the electron away from the anode and pulls them toward cathode is called electromotive force. That is EMF. Cell potential. The SI unit of cell potential is volt. So when there is 1 volt difference in electrical potential between anode and cathode, 1 joule of energy is released for each coulomb of charge that moves between them. So 1 joule equal to coulomb into volt. So J equal to C into V. The cell voltage depends on the nature of the electrodes, the concentration of the electrolytes, and the temperature at which the cell is operated. For example, at 25 degree Celsius, the EMF of the below mentioned Daniell cell is 1.107 volt. 1.107 volt. Here galvanic cell notation is given. So right side EMF value, standard EMF value also is given 1.107 volt. Now measurement of electrode potential. How to measure electrode potential? Just look at the diagram. It is standard hydrogen electrode. Standard hydrogen electrode. Hydrogen gas in and hydrogen gas out. Okay. Here it has a solution, that is hydrochloric acid. The concentration 1 molar and the hydrogen gas 1 atmosphere, and the temperature that also maintaining 25 degree Celsius. So these are the conditions takes place in the electrode. That is called standard hydrogen electrode, SHE. SHE. It has been assigned an arbitrary EMF of exactly 0 volt. So how much volt it is releasing out? Exactly 0 volt. It consists of a platinum electrode in contact with 1 molar HCl solution and 1 atmospheric hydrogen gas. The hydrogen gas is bubbled through the solution at 25 degree Celsius. Standard hydrogen electrode can act as cathode as well as an anode. Cathode as well as an anode. Now, if the standard hydrogen electrode is used as a cathode, the reduction reaction EMF equal to 0 volt. Right? So, cathode act as a cathode means it accepts 2 electrons and it forms hydrogen. If the standard hydrogen electrode used as anode, oxidation reaction is it releases 2 electrons from hydrogen gas. Hydrogen cation will form. So anyway, it gives 0 volt. Now measurement of electrode potential. How to measure the electrode potential in anode compartment? In anode compartment by using standard hydrogen electrode. Here the EMF measurement is given of zinc strip dipped in zinc sulfate solution. So left side anode compartment consists of zinc strip dipped in zinc sulfate solution. So right side standard hydrogen electrode. Standard hydrogen electrode. Here act as reduction. Standard hydrogen electrode act as reduction. Now we can measure the volt. Digital voltmeter, we can measure the volt. It shows 0.76. 0.76. These volts denote only the anode compartment, because the standard hydrogen electrode volt is 0. Let us calculate the reduction potential of zinc electrode dipped in a zinc sulfate solution using standard hydrogen electrode. Step 1. EMF notation, we have to write it. So zinc vertical line, zinc 2 plus, vertical line means phase boundary, then it is left side, then right side H plus turns to hydrogen gas, platinum, that is the electrode. Step 2. The EMF of a above galvanic cell is measured using a voltmeter. So in this case, the measured EMF of the above galvanic cell is 0.76 volt. Okay. Then we know that the formula EMF cell equal to oxidation plus reduction. So oxidation, zinc strip dipped in zinc sulfate solution, reduction standard hydrogen electrode, actual value 0.76. 0.76, reduction value 0. So after substituting we can get it. Oxidation compartment, anode compartment gives 0.76 volt, it is for zinc. The EMF for the reverse reaction will give the reduction potential. The EMF for the reverse reaction will give the reduction potential. Keep this point in your mind. So the value will be negative. 0.76 will be in negative. So minus 0.76 volt. So IUPAC definition, electrode potential, electromotive force of a cell in which electrode on the left is a standard electrode and the electrode on the right is a electrode in question. Standard electrode potential E power naught, that is a standard electrode potential. The value of the standard EMF of a cell in which molecular hydrogen under standard pressure is oxidized to solvated protons at the left hand electrode. Thank you.